Hello everyone. So in this video, I'm going to talk about enzyme inhibition, and I'm going to go over competitive, non-competitive, and uncompetitive inhibition. And I'm going to compare how each and every one of them is going to affect different parts of the enzyme kinetics and how they're going to look on the Line-Weaver-Burk plot. So before I get into the video, I'm just going to go over the Line-Weaver-Burk plot and what it shows. So the Line-Weaver-Burk plot is a double reciprocal plot, and the y-axis is 1 over the speed of the enzyme, and the x-axis is going to be 1 over the substrate concentration. The two most important things that we need to know is that if we have a line like this on the plot, the y-intercepts here is going to be 1 over Vmax, and the x-intercept here is going to be negative 1 over Km. Another thing that we need to pay attention to is the slope of the line, and there are sometimes some questions about that. And the slope of the line is going to be Km over Vmax. So this plot is really important for the MCAT and to solve the enzyme kinetics questions. And I'm going to go over how this plot changes in different kind of inhibition. In competitive inhibition, the inhibitor attaches to the active site of the enzyme. So if this is the active site, the inhibitor is going to block the substrate from attaching. And this would decrease the affinity of the enzyme for the substrate, which in fact would increase the Km of the enzyme. In competitive inhibition, if we increase the substrate to like an infinite amount, we are going to override this inhibition of the active site, and the substrate is going to take over eventually. And because of this, the Vmax of the enzyme does not change in competitive inhibition. So if I want to go over the Line-Weaver-Burk plot, of competitive inhibition, it's going to look something like this. We know that Vmax is not going to change, so the y-intercept is going to be constant. But as the Km is going to increase, because we know the x-intercept is negative 1 over Km, as the Km is increasing, we know the intercept is going to be moving closer and closer to 0. So if the first line of the enzyme without the inhibitor is something like this, as we increase the inhibition, it's going to move to the right, but it's going to intercept in the same y point. So it's going to look something like this as we add more and more inhibitor. And one of the most important things to notice here is that the slope of the line is increasing. And as I said, slope is Km over Vmax. And we know that in competitive inhibition, Vmax is constant. So as Km is increasing, the slope is also increasing. And we can see here how it shows. So in uncompetitive inhibition, the inhibitor only binds to the enzyme substrate complex and kind of locks it in that position. So if we have the enzyme plus the substrate, which would give us the enzyme substrate, the inhibitor only attaches to this, which would give us something that looks like this. This ESI complex is basically the enzyme plus the inhibitor, and by locking the enzyme in this position, we are eventually going to decrease the Vmax because the efficiency of the enzyme is being reduced. But one of the most important things about uncompetitive inhibition that we need to know is that the affinity of the enzyme is actually increasing, lowering the Km. And the reason that this is happening is because as we are creating more and more ESI, the amount of the enzyme substrate complex is decreasing. And in every reaction, we are looking to reach equilibrium. And because this is decreasing, the reaction is going to move to the right to increase the ES complex. And the only way we can do that is to increase the affinity of the enzyme for the substrate, which is going to basically reduce the Km. And this is basically the reason that the affinity is increasing. The Line-Weaver-Burk plot of the uncompetitive inhibition, I think this is the most simple one to know, because we know that the slope of the line is basically Km over Vmax. And because both of them are decreasing in uncompetitive inhibition, as we add the inhibitor, the slope of the line is going to be constant. So whenever you see the added lines have the same slope, it's always going to be uncompetitive inhibition. And just one important thing that you guys need to know is that, well, we see the parallel lines, we know the slopes are the same, so we know it's uncompetitive. But what's the difference between if it's above or below the original enzyme line? Well, we know the y-intercept is 1 over Vmax. And if we increase the Vmax, we are actually going to decrease the intercept point. And decreasing Vmax, on the other hand, is going to move the line higher on the y-intercept. So as we decrease Vmax, the interception of the y is going to become higher and higher. So basically, this line is going to be higher concentration of the inhibitor, and this line down here is going to be lower concentration of inhibitor. So in non-competitive inhibition, the inhibitor attaches to an allosteric site, and this site can be on the enzyme or it can be on the enzyme substrate complex. So basically the inhibitor can attach to both, creating the enzyme inhibitor or the enzyme substrate inhibitor complex, or ESI basically. So because the enzyme inhibitor attaches to an allosteric site, it does not change the affinity, so Km is constant. But the enzyme speed, on the other hand, it's going to be reduced because the efficiency of the enzyme is being decreased both on the enzyme substrate and on the enzyme itself. So Vmax is going to be decreased. So the Line-Weaver-Burk plot of non-competitive inhibition looks something like this. We know that the Km is constant, and we also know that the x-intercept is -1 over Km. So if the original enzyme line is something like this, the x-intercept is always going to be the same because the Km is constant. But the Vmax is being decreased, and we know the y-intercept over here is 1 over Vmax. And as we decrease Vmax, and because Vmax is in the denominator, the next lines are going to be higher and higher on the y-axis. So as the inhibitor concentration is increasing, we are hitting the y-axis on the higher and higher points. And if you see a Line-Weaver-Burk plot that has the x-intercept in the same position and it's kind of like moving upwards like this, it's always going to be the non-competitive inhibitor. Okay, so to wrap up the video, I'm just going to go over each of the kinds of inhibition and what they look like on the Line-Weaver-Burk plots. So in competitive inhibition, we know that the Vmax is constant. So the y-intercept is never going to change. but we know the affinity of the enzyme is decreasing, increasing the Km. So as the Km, which is on the denominator, is going to increase, it's going to make the intercept go closer to the zero. So if you have a line that's on the right side, it's going to be a higher inhibitor concentration. But if we see this line over here, you can see that the intercept is on the left side of the original line, which shows that the inhibitor concentration is lower than the original amount. In uncompetitive inhibition, we know the Vmax and Km both decrease, and that's the reason that the slope is always constant. But to know which line is which, the black line is the original enzyme, we know the Km is decreasing, meaning that this line is going to be moving to the left. So as we increase the inhibitor concentration, the lines are going to move to the left, away from the zero. So they basically become more negative. But if we decrease the inhibitor concentration, we are going to make this go to the right. And in the end, the non-competitive inhibitor, we know the Km is constant because it only attaches to allosteric sites. So the x-intercept is always going to be in the same place. Now we know the Vmax is going to decrease as we increase the inhibitor concentration. So we know the y-intercept is 1 over Vmax. So if we add more inhibitor, decreasing the Vmax more and more, we are going to have a higher and higher y-intercept. And on the other hand, if we decrease the inhibitor, we are going to decrease the intercept on the y-axis. Well, I hope you guys enjoyed this video about different kinds of enzyme inhibition. And if you like this video, please follow my channel for more videos like this. Thank you for watching, and I am going to see you guys in the next video.